Good morning, good evening, or good afternoon, depending on wherever you are joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Accelerating DevOps with Azure. Before we get started, I would like to go over a little bit of housekeeping announcements. We do have subject matter experts with us today who will be answering questions in real time. So please pop any questions you might have into the Q&A window, and we will get to them as quickly as we can. Also, on the bottom left-hand corner of your console, you will find a resources area. Any links which are mentioned or talked in this session will be accessible for you there. Right below the resources widget, you will find a survey. Please provide any feedback you have around today's session. Finally, this session is recorded, so you will receive a copy of this presentation in your email within 48 hours. With that, let's get started. Keeping pace with mission demands during these days is an increasing challenge for any organizations. Developers are on the hook to deliver new capabilities to their end users and customers faster than ever. So getting all right with DevOps requires huge effort, but at the end, if you look at the benefits to your organization and the customers can be huge. Microsoft has a set of fantastic products that can help you to get most out of the cloud with any language or any platform. In this session, I will talk about how to transform your team to adopt DevOps, also how DevOps and cloud can help the partners and customers to accelerate their mission, speed, and capabilities. If you have any feedback or queries, feel free to reach out to me using the social handles which are displayed there. Let me talk a little bit about today's agenda. We wanted to have this session applicable to all the participants. Hence, I will start with an introduction to DevOps and brief about why organizations needs to have DevOps practices. Then I will dive into some important concepts if you're building software products covering continuous integration and continuous delivery. Also, I will talk about the best practices for building the right pipelines for your software products. Also, it is very important to cover what Microsoft offers in DevOps space, starting with Azure DevOps, GitHub, and AppCenter. Then I will have a demo. I will go through some of the features of Azure DevOps, AppCenter in general, but if you have any specific scenario, drop us a note so that we can help on those areas. And finally, we will have some questions answered, so don't forget to stay at the end for the Q&A session. I always like to start about the topic with an analogy. So for those who are very new to DevOps, imagine you and your friends are going to play the telephone game. I have played this game a lot of time and it's fun. I'm sure most of you might have played this game already, but for those who don't know, the game is that person A says something to the person B, then person B repeats what he or she thinks the person A has told. Then it goes to the person C and D and then so on. This explains the flow of information in the large teams while building any software products or any product that you can think of. Here is how one would explain an IT organization without DevOps, where devs and the operations teams are in constant silos and just do the flow of information, right? DevOps is like a telephone game where everybody actually understand each and every word and act accordingly. For me, DevOps is a culture. It's a way of thinking that both devs and the operations team has to adapt in order to work together well. The most important requirement here is clear and transparent communication between the teams. Then, it can begin with the definition of the required documentation for a software, or it could be the logging and the security policies that you need to have in your software. Then using automation implementation tools to help the teams to accelerate their productivity and work faster together. There are thousands number of definitions for DevOps. They tend to focus on narrow disciplines or technologies. But if I have to give a definition, I will go with this very famous person's definition, who is my guru of DevOps, and for many as well, who is Donovan Brown. As he states, DevOps is the union of people, process, and products, which enables the continuous delivery of value to your end customers. Every DevOps discussions have three elements, right? One is people, process, and the products. Where people or culture is about bringing people together in a collaborative fashion that enables multidiscipline teams to work together more easily, which is about sharing common goals and focuses on identifying the areas for improvement. And the process is about finding ways to increase the efficiency, also streamlining the feedback and eliminating the wastages as well. All software development processes should be focused on delivering the business value faster, focusing on the flow of values, right? And finally, the tools which supports the process and facilitate the continuous feedback and the experimentation. The DevOps tools or products can be from different vendors. Throughout the session, we will talk about the important pillars of DevOps, such as continuous integration, continuous management, release management, infrastructure as a code, application performance monitoring, continuous delivery, and automated testing. Let's start with the $1,000,000 question. If I ask you this question, whether DevOps is it for everyone, the answer is yes. Software is everywhere in today's world. Every major company or organization is related to software development, and they need to behave as one. There is more pressure than ever to move faster and to be more agile without sacrificing on security and reliability to their end customers. This is a situation where DevOps seeks to address how to get development, operations, and other groups within the organization to collaborate around a set of shared goals to deliver software faster and reliably to the end customers and the end users. These often includes, automated configuration management, testing, and application deployment. It also includes about version control of the application and infrastructure as a code to enable collaboration across teams and code reuse across teams. And also, whenever rollbacks needed, it's really important to roll back to the previous version. It also talks about continuous integration to automate code builds and enable faster feedback and iteration through more frequent and more frequent releases. So DevOps is all about a culture. It's not a specific role. The whole company needs to be doing DevOps to make it to work. If I have to put this way, how often do you release features to production environment? If you're having the right practices, you should be in a position to deploy in quick time based on customer requests whenever possible. Back in 2011, when I was a junior developer, I have had this experience of deploying more than 10 times to production environment for a small bug fix. And that time I didn't have any proper DevOps practices, right? If you take GitHub, the team is constantly deploying dozens of times a day. When someone pushes to the master branch after watching the test passes, they are encouraged to immediately deploy to production. This way, everyone is responsible for their own code being production ready. And people don't have to worry about pushing some things or someone else's codes and breaking the production environment. This is a fantastic way of doing things. Deploying constantly means we completely avoid the scary things such as deployment days, where people talk about deployment on Fridays. And our fast and painless deployment process means we can quickly fix problems as they are discovered. 50% of the Fortune 500 companies are now replaced by organizations that uses the technologies to deliver customer values faster, better, and cheaper. In a technology-driven world, developers are at the heart of your company's feature innovation, right? DevOps is about starting from the first lines of code to how you give your developers the best tools to unleash their capabilities and make them their best productive. Also, productivity doesn't just come from great tools. You also need to facilitate the collaboration between them, and also you need to make sure that you have the code reusability across teams. This accelerates the problem solving and also focuses on solving new problems which are very relevant to your business. According to the 2018 State of DevOps reports, the top performing DevOps companies have 66% less time on customer support issues. And if you see 50% less time on defects and the remediation of security issues. More importantly, they spend 66% more time on new work, which means that they spend more time in innovating, which is about enabling them to be more adaptive in their markets and also about disturbing their competitors. Using DevOps practices, you can deliver software faster and more reliably, no matter how big your IT department or what tools you are using. It involves things about continuous integration, which is about improving the software development quality and speed. Each time, whenever you commit a code, it is automatically getting built, tested, and the bugs are detected even faster. Second is about continuous deployment, which means by combining the continuous integration and infrastructure as a code, you will achieve identical deployment and the confidence to deploy to production at any time. With continuous deployment, you can automate the entire process from the code commit to production if your CI/CD tests are successful. Third is about continuous learning and monitoring. With monitoring tools such as Azure Application Insights, you can easily identify how your applications are performing at your customer environment and test if the recent deployments made things worse or better. Using CI/CD pipelines paired with monitoring tools, you will be able to safely deliver features to your customer as soon as when they are ready. So Microsoft Azure is a powerful and flexible foundation for past, present, and future applications, which lets you to easily build, manage, and deploy applications to any platform with any stack on a massive global network using your favorite tools and frameworks. So this visualization depicts how an end-to-end product development is automated with the help of DevOps practices, which covers about people, process, and the tool. I hope you got a clear understanding of DevOps in general. If I have to tell you the importance of continuous integration and DevOps, this is a story worth telling 1,000 times. Most of you might have heard this story. Just to give a glimpse about this particular incident, Knight Capital Group is an American global finance services which lost about $460 million in 45 minutes due to something they termed as a trading glitch. Everyone was expecting the launch of software on August 2nd at 9:30 a.m. and it took, with only one defect in their trading algorithm, they have to lose $460 million in 45 minutes. That $460 million is 3 times the company's annual earning. This is a real story reflecting that they didn't have a proper DevOps practice in their company to prevent this disaster. The reason I shared this story is to understand the importance of having the right practices, even if you are building a small software. With every code change you make, you can assure that your deployment is going to be as per your expectations with lesser time deployment. With DevOps, life of not only the developers but the operations teams have become very easy, as they don't need to be depend on each other in order to deploy applications to productions. You can make sure of the successful deployment unit within the given time frame. Also, you don't need to control over the different environments, which can be automated. Continuous integration is a practice of making changes to source code made by a single developer available as frequently as possible to other developers using the same source code. It is about team of developers working together in the same code base. So each developer needs to do things like, locally develop new features using the latest code. There might be building and testing the code locally. There might be chances that merging those changes into a shared source code repository by linking the associated tasks. So if you look at the top 5 goals of continuous integration, it makes developers to collaborate easily to deliver features faster. It enables parallel development by minimizing the integration depths. Also, it makes sure that the code quality is checked and acts as a quality gate to prevent any defects. And finally, it helps you automate everything from local environment to anywhere you want to deploy. If you take continuous integration, there are 3 key elements that it comprises of. The first is the version control system. How many of you have this experience? You run the application and something doesn't work. You say that worked yesterday. And I swear I didn't touch that code or class or method, right? I have done that in the past. If you are checking in code regularly, a quick diff would show exactly what had changed in the last day. Even as a single developer, source control offers a great benefit. It allows you to store your code's history and revert back to the previous versions of your software at any time. This allows you fearless flexibility to experiment because you can always restore to another version of your source code that was working earlier. The second thing is about the branching strategy. If you're building a software, branching strategy is a key factor for developers and even for any organization that you're building software. You can follow a lot of sophisticated strategies, but in some circumstances, those strategies have been a good fit. In 99% of the time, if you're working in one team, the simple one branch per ticket strategy turned out to be the best. Mainly because it's simple, and also if you are a developer, you need to commit things often, keep the changes minimum as possible. Third thing is about the automated build, key component of the continuous integration, and you need to be sure that you are running the automated build whenever you are merging a pull request uh, to the certain branch. Every time a developer checks in and enable the quality of the code with some static code analysis, you need to make sure that everything falls in the right place. Also, you need to make sure that the build run faster so that developers can check the feature then and there. These are some of the important elements of a continuous integration. Let's talk about some of the practices of continuous integration. When you think of repositories, they are of two types, right? One is monorepo, which is a single source control pattern where all the source code is kept in a single repository. This makes it simple to get all your teams access to everything in one shot. The second type is the multi-repo, which refers organizing your project each into a separate repositories, which makes the continuous integration easier. When it comes to branching goals, you need to keep the branching strategy simple as possible, and master branch should be always ready for production. And developers need to merge to master as fast as possible, and also keep, feature branches as short-lived as possible. Next, on the branching policies, you need to set a minimum number of reviewers on pull request and check for linked work items. Always check the command for resolutions, and you need to enforce a merge strategy so that you are always committing the right code. And build validation will make sure that latest commit doesn't break the features. If you have a large team, make sure automatically include the specific code reviews, and it's always good to build parallelization using separate jobs and dependencies. You need to enable parallel builds to make sure that your build and the product is consistent. Ensure that the build results are getting triaged for quality purposes so that the code is valid before merging to the master. From the developer's perspective, you need to ensure that you are covering 100% on the unit test and make sure that the pull requests are created whenever you merge, and secure scanning is done through any reliable tool before merging. These are some of the best practices that you need to ensure in continuous integration. This is how the end-to-end flow on a continuous integration would look like, from creating a local feature branch to completing the commit and merging to the master. I will not go in detail, but you can see the three figures which indicates the three stages. But how will you do the end-to-end process from writing the source code to pushing into production? Let's talk about the importance of continuous deployment. This is a research done by the authors of Accelerate book, which talks about the importance of continuous deployment on work life. You need to ask this question to yourself: how big is your deployment pain to production? This single and the most important question is asked to understand the delivery performance in an enterprise or any organization. The fear and the anxiety that the developers and the engineers and the technical staff, when they push code into production, can tell us about the team's software delivery performance. This has been the case in many organizations. So you can always determine the fear of deployment to production to ensure that how good quality DevOps practices that you are following in your organization. Continuous delivery is a software development process where the development phase is more streamlined to allow fast and efficient deliveries to production. Continuous delivery method requires ensuring that it can always be in a state where it can be immediately deployed. When you talk about the important practices, you need to think about the deployments are scripted or automated via the automated deployment tool. Automated deployments are configurable, repeatable, and reliable using those tools, right? Deployment automation and artifacts are stored and maintained in the source control system. You need to use the same process for all deployment across different environments. The automated deployment process includes something like automated smoke testing as well. Building once and deploying to all environment ensures that it passes the quality checks across different environments. Uh, some key things to be noted are if the application breaks after deployment, you need to fix it, commit the fix, and redeploy it. Do not revert to the previous version. I have seen this happening with most of the developers. You need to make sure that you are fixing you need to make sure that you are applying the right fix and then redeploy, not to revert back. Your team should have the mentality of done means deployed and working as expected on the target environment. Most of the developers, including me, we tend to fix on the production itself. You need to ensure that no quick fixing on the target environment is done. Anything that goes to the target environment gets there via the automated deployment process. These are some of the good practices in continuous delivery. With that, I also have to emphasize about canary deployment and blue-green deployment. Both methods ensure that you deliver right software to your end users. A canary release is a test that is used to analyze how a software update might impact the user behavior. This is done by creating a canary cohort or a small group pull from the user base. The cohort is produced from a random sampling of 1% of all users. This group will constantly have the new feature turned on, while the rest 99% of users will continue using the old features. As shown in the diagram, this approach is being widely used by many of the product development companies, which are proven to be very relevant for every company. And the second thing is the blue-green deployment. Blue-green deployments are a pattern where we reduce the downtime during a production deployment having two production environment. One is named as blue and the other is termed as green. One of the challenge with automating deployment is the cutover itself, taking the software from the final stage of testing to live production. I would highly recommend to enable this practice in your organization in order to, make it to a level of zero downtime for your applications. Let me talk about what are the different offerings from Microsoft in order to adopt DevOps in your organization. The first one I'm going to talk about is Azure Devops, which is a service shared with both our internal teams and our customers based on the heritage of our on-prem Microsoft Team Foundation service, which is named as TFS product. It provides an end-to-end DevOps toolchain for developing and deploying software. It also integrates with most of the leading tools on the market and is a great option for orchestrating DevOps toolchain. Let me talk about some of the features it provides as a centralized solution in one place. Continuously delivering value is about more than just automating the deployments. You must start at the beginning of your software development process. What you plan to deliver and how you plan to get there. In other words, it's all about planning and tracking. Your projects usually start with an idea and a plan on how to turn this idea into a reality. Usually, Agile approaches software development by emphasizing incremental delivery, team collaboration, continual planning, tracking, and learning. Although the planning starts the process, the development teams turn those ideas into features and capabilities during the development and the testing phase. So your development team will use the practice of continuous integration to merge the code and automatically run a build process, including tests whenever they whenever they commit a code change. Continuous delivery will deploy your build to testing, pre-production, staging, and other environments in the release process. It gives you a quality gauge throughout your release pipeline and increases the confidence in your code long before production release. Lastly, you need to watch your solution in production. Effective monitoring delivers information about your solutions performance, usage, and the issues at your customer environment. It is essential to enable DevOps teams to deliver at speed, get feedback from production, and increase customer satisfaction, acquisition, and reflection. Whether you are targeting the cloud, hybrid cloud, or an on-prem environment, Azure DevOps is the recommended DevOps solution. It allows you to plan, monitor, build, and deploy to Windows, Unix, Android, iOS, irrespective of any language that you use, such as .NET, Java, Python, Ruby, and many other third-party and open source products such as Maven, Gradle, NUnit, XUnit, and things like that. If you cannot find the task needed for your release pipeline, you can build your custom task that integrates with Azure DevOps and your continuous integration and the continuous deployment so that you can deploy your solutions to any customers in any environment. This slides depicts different tools and the technologies that you can leverage with Azure DevOps in order to build your solution and deploy to your customers. Azure Pipelines is the Azure DevOps offering for the heart of your DevOps needs when it comes to continuous integration and deployment. Azure Pipelines is the perfect launchpad for your code. It automates everything from your builds and the deployments. So you spend less time with the nuts and bolts and more time in delivering value to your business. At Microsoft, we just do that. We deploy over 78,000 times a day with Azure Pipelines. It's great for any type of applications, any platform, or any cloud. It has cloud-hosted pools of Linux, Macs, and Windows VMs that we manage for you. You are also not restricted to the functionality we provide. Pipelines has a rich extensibility so partners and the community can contribute extensions in our marketplace for everyone. If you want to build and test a Node app in GitHub repo and deploy it via Docker container to another cloud or on-prem, you can just do that. Containers are becoming more and more the unity of deployment, and Azure Pipelines are great for containers. Azure Pipelines can build images, push them to a container registry like Docker Hub or Azure Container Registry. You can deploy to any container host, including Kubernetes environment. With Azure DevOps release management, you have the full control on what environment exists, who can access them, and what is the process to deploy releases from one stage to the next. Pre and post deployment can utilize either approval or gates for approval. There are two kinds of options. One is approvers, who are designated people who have authority to manually approve or reject a deployment. And the second type is the gates, which is an automatic condition that must be met to move forward based on the Azure Monitor or invocation of Azure Functions or REST API or a query on Azure Board's work item. So these are different options that you can have, approval or gates for approval. Azure DevOps is now available over Express Route, which lets you to connect to any environment. Let's dive in and see what defines a good pipeline. You need to enforce branch policies which can help the teams to protect their important branches of a development. Policies enforce your team's code quality and change management standard. Some of the important things are you need to collaboratively decide on the branching workflow which suits your project needs. Also, limit the merge types. You need to decide whether which strategy that you are going to follow as a team, whether it's a basic merge or a rebase with pull requests or squares merge so that it avoids confusion and conflicts. If you consider master branch as the main branch, you should restrict direct commits to master branch as it always be in a ready state to deploy to production. Avoid committing dependencies to the branches, which most of the developers tend to do. Let's move to the next step, which is about setting pull request policies. Code reviewers are the best practice for most software development projects. To require teams to review their changes before completing a pull request, you need to select or set at least a require minimum number of reviewers for particular pull request. As mentioned earlier, linking work items provides additional context for your changes and it ensures that updates go through your work item tracking process. Configure a command resolutions policy for your branch by selecting, check for command resolution, which makes that developers are fixing the pull request commands and ensuring those are free from errors. Pre-deployment gates ensures that there are no active items in the work item or any issues related to that. Let's move to automated build. On the automated build process, there are 3 things needs to be followed. Make sure that you are merging the pull request in the correct manner and to the right branches. Whenever a new code is committed, it needs to trigger a build and ensure that the quality gates are being checked and passed. Once the build is successful, it needs to create an artifact which can be deployed to any environment. When it comes to automated release pipelines, you need to ensure the following steps. Whenever a new build is invoked, it has to generate a new release and the version needs to be incremented accordingly. If you have set gates for approval or any pre-deployment conditions, it needs to pass through the approval. And then the deployment happens according to the configured environment. And finally, if there are any post-deployment conditions, which needs to be met as well. Some key considerations on the pre and the post deployment, such as, if you're having multiple environment or following a monorepo strategy, add pre and post deployment conditions to match your workflow. Always consider pre-deployment approvals when you are deploying multi-environment. You can write your custom conditions or gates to check the other status and generate a notification to the relevant developers. And make sure to decide on the deployment queue settings, which allows you to configure actions when multiple releases are queued for deployment. You can configure artifact, for example, on the dev stage that only triggers the dev release for artifacts from the development branch, and an artifact filter on the production stage that triggers the production release for artifacts from the master branch. So these are some of the considerations that you can have. Multi-stage deployment feature allows you to split the deployment process into multiple stages and reuse them across multiple projects. Azure pipelines provide a highly configurable and manageable pipeline for releases to multiple stages such as development, staging, QA, and production. It also offers the opportunity to implement gates and approvals at each specific stage. As a developer, let's see how I can incorporate all the practices that we discussed so far. Assume I got a new requirement from the customer in order to integrate a new feature. The feature is available in the Azure board as a work log item. I'm going to fetch that work log item from the Azure boards, and then I will be creating a new branch in my local machine, which is the feature branch. Once I build the feature branch using any of the programming language with any of the IDEs such as VS Code or Visual Studio, I will be pushing the source code to the source control by creating a pull request to the development branch. Once the pull request is merged to the development branch, it will be creating a build trigger, which is going to fetch the source code from the particular source control, and then it will install all the dependencies or packages that are needed to install. It will be following the process of build, test, and do the code analysis if I have integrated with any of the code analysis tool, and it will follow the security test and publish those artifacts to the path I have mentioned. Once the build is successful, it will be triggering a release. You can see which is based on the release pipeline. It will be fetching the artifacts from the place where I have mentioned, and it will provision the environments based on the ARM templates that I have provided. It will be creating the resources and deploy the code respectively. And finally, I want to do some functional testing or security testing and load testing using some of the test plans that I integrated with Azure Devops. I can see that once the release is successful, it will be deployed to the dev environment where I can do the initial testing and hand it over to QA to do the end-to-end testing. On the QA environment, it has to go through the approval process. As a developer lead, my lead can approve the release to the QA environment, and then it will follow the same approval process from the QA lead to the UAT environment, and then it will require an approval from the product owner to deploy to the production environment. This is how the end-to-end deployment to production would look like by integrating some of the best practices that we discussed today. I do not have to stress about this. At Microsoft, we love open source. As you can see in this particular slide, which I will be not diving in detail from 2012 to 2020, every year we do more and more in the open source space. You could see from the fact that how we embrace the projects that community has embraced, starting from Linux to Kubernetes, or the ways we increasingly open source the softwares we work on, from .NET to VS Code and TypeScript and so on and so forth. In fact, much of the core tech in Azure pipelines is open source. One of the collaborations that happened in 2018 is the acquisition of GitHub. GitHub is the premier developer collaboration platform from Microsoft. GitHub is the home to biggest open source community in the world. I'm a true GitHub fan, and if you really see the innovations happen in the GitHub, it's truly amazing, starting from GitHub Mobile to the recent announcements of GitHub Code Spaces, which enables the developers to write code from any device. There are 50 million developers across the world using these features on a daily basis. One of the features of GitHub I wanted to highlight today is the GitHub Actions. GitHub Actions makes it easy to automate all your software workflows. Now with world-class CI/CD pipelines, you can build, test, and deploy your code right from GitHub. GitHub Actions needs to be written in YAML format, whether you want to build a container, deploy a web service, or automate welcoming new user to your open source project. There is an automated action for all of that. There are equivalent terms available in GitHub Actions as well, which you can explore more about. Step, which is the smallest instance, which can be a command or an action. An action, which is a predefined step, which can be used and shared. Also, it can be embedded in multiple steps. A job usually combines multiple steps running on the same OS and can be started in parallel or in sequence as well. And workflow is the one or multiple jobs, including a triggers, which is in a YAML-based manifest. With the availability of GitHub Actions, you can always connect to Azure Devops as well in order to, connect with Azure pipelines and also Azure bots. Another offering in terms of provisioning the environments is the Dev Test Labs. Whether you are already started implementing DevOps or looking to get started, a common challenge for IT organization is keeping up the project with demand for developing and test environments. Dev Test Labs simplifies the environment management for dev and test environments in the Azure cloud. It provides self-service access for teams with developers with policies to control cost and enforce the use of appropriate images and artifacts. Let's talk about the infrastructure as a code in brief. Infrastructure as a code evolved to solve the problem of environment drift in the release pipeline. Without infrastructure as a code, team must maintain settings of individual deployment environments. Over time, each environment can become a snowflake that is unique configuration that cannot be reproduced automatically. Inconsistency among environments leads to multiple issues during the deployments. Administration and maintenance of infrastructure involves manual process which were hard to track and contributed to errors eventually. With the infrastructure as a code, you can deploy the releases to production repeatedly and also reliably. Azure Resource Manager provides these capabilities for Azure out of the box and works across Azure as well as the Azure Stack. But if you're already using third-party tools such as Terraform, Ansible, or SaltStack, we already support those to deploy resources on Azure as well. It is always not about continuous integration and deployment. You need to always have a visibility on what is going on your custom environment and have the ability to overcome issues if there are any. Azure Security gives you flexibility and control of your entire cloud and the security state of your environment. It uses analytics to provide proactive recommendations across both Windows and Linux. You can also leverage services like Azure Event Viewer to track access, like who is seeing and who is doing what and when. With Azure Security Center, you can gain full visibility and control of your cloud security with a single unified view from different sources, which protects the environments from different attacks. Azure Monitor solutions provide predefined solutions with a smart threshold and intuitive dashboards, so you can start getting insights straight away. Azure Monitor provides metrics for Azure infrastructure, building upon you can leverage both log analytics and application insights to gain greater insights into your infrastructure and applications respectively. By leveraging both of these tools, you can build a dashboard for both of your developers and as well as your operations team. With these tools, you can also automate and integrate into existing, service desk platforms such as ServiceNow or anything that you use already. There is always a question among developers and the partners around DevOps and GitHub. The guidance is that there will be definitely a transition from Azure DevOps to GitHub down the line. To answer it simply, GitHub Actions is the best option for customers leveraging GitHub as their main source control repository or looking to adopt modern CI/CD actions powered by the community. If you have CI/CD needs that are not met by GitHub Actions in near future, continue to use the Azure pipelines, and there will be always support available on Azure pipelines. While Azure DevOps provide end-to-end features connecting from different sources and have more capabilities, but eventually those features will be available in GitHub as well. If you are a fan of ARM templates, you should definitely check this out, which came out from the Ignite announcement last year. Project Bicep, which is a ARM template domain-specific language, which helps developers to build ARM templates quicker and easier. The main motive of Project Bicep is to drastically simplify the whole process. I wanted to learn a little bit more about Project Bicep, and I was translating one of my ARM templates to it, and it was very useful. In addition, the documentation provided in the GitHub repository of the project is awesome, and it's easy to follow. So go and check it out today. This is the demo that I wanted to cover today on how to deploy a multi-containers application to AKS and then deploy with disk spaces. I have already created this particular environment in my local machine, and I will not be replicating on how to create the CI/CD pipelines and how to create the AKS cluster. I just wanted to demonstrate the capability of having Azure Dev Spaces in order to debug the application in real time and then enable the CI/CD to deploy the application quickly to the production environment. You can try out this demo using the URL provided, but let me quickly show how I have done this in my local machine. I have already deployed this application using Kubernetes cluster with the CI/CD pipelines on Azure Devops. Hence, I am logging as a user to this application, which is deployed on AKS. And if I log into the application as a user, I was able to see the dashboard. And if I navigate to the doctor's page, where I can see that doctors' names are ordered in the correct ascending order. But if I navigate to the patient's page, I can see that names are not ordered in the proper ascending order. This could be a potential bug that the customer is reporting, and I need to fix this immediately as soon as possible. One of the features that comes with AKS is the dev spaces, which enables the users to replicate the environment in local machine without having to create the Kubernetes cluster. Hence, I need to enable the dev spaces in my Kubernetes cluster and navigate to my Kubernetes cluster, which is on Azure, and then enable the dev space. As you can see the solution being loaded, and if I navigate to this particular solution, you can see the particular controllers, the microservice controllers are being opened. And I need to enable the dev space in my Visual Studio. So I need to set up my Azure account with the Kubernetes cluster that I already created and enable the dev space. What it does at the back end is it is going to create the same cluster that we have in the production environment in your local machine, so that all the images that we have deployed to the containers, it's going to be available in local to debug. As you can see, there is a similar environment which is created, and if I log into this particular environment, I can see that issues being replicated. It is going to navigate to the breakpoint where I have added and see what is the mistake that we have done. As you can see, I have not added the order by command, so the error is so obvious, right? Hence, I will go and add the order by command just to fix this bug so that we can deploy quickly. And if I navigate to the application using the same user, you should be able to see that application is working correctly and the bug has been fixed. Since I have the continuous integration and continuous deployment in place, I can commit this code to the source control and then create a pull request to merge with the development branch. So whenever I push this code, it's going to trigger a build and deploy the application to the dev environment so that QA can do the testing and push it to production. The second demo is on the AppCenter. In this demo, I will show an overview on how you can leverage AppCenter in order to build mobile applications using different platforms. You can navigate to appcenter.ms and then log in with your credentials or GitHub account in order to view all your apps that you have deployed. In this case, I am navigate to this particular organization in order to see the number of applications that I have deployed. If I navigate to this particular application, in order to integrate analytics to your application, you can add this particular code in order to have the telemetries coming from your device. And if I navigate to build, you can see the pipeline that I already have so that the number of builds that happen, number of failures, and number of successful build and things like that. And if I go to test, you can see the number of tests that have been successful and executed. And if you want to run new tests, you can do that. Also, if I navigate to devices, there are a number of device sets that I have already tested, but if you want to test on a new device, you can enable by navigating to new device set. Also, you can distribute applications based on different versions and then group them together using, the version number. And if I navigate to diagnostics, this is where you can see the telemetry, so the crashes that is happened for this particular application. If I navigate to analytics, you can see that the number of users who are using this particular apps from different region, and also if there are any, you can see the metrics in terms of users, in terms of session, in terms of top devices and things like that. AppCenter makes it easier for mobile developers to have the version management, to distribute applications, and also to have the telemetries coming from different users. And you can see that you can also export this analytics to Azure Application Insights so that you can leverage that data to build some dashboards and things like that. This is a quick demo on AppCenter. So if you're building any mobile application, this is something that you can try. With that, I would like to end my presentation today. You can post your questions in the Q&A window. Thanks everyone for joining. We will meet again with another webinar. Until then, bye and stay safe.